So let's dive into solving linear equations. All right. The main key concept with solving linear equations is we want to get our variable by itself. So we have to undo the order of operations. So whatever we do to one side, we have to do to the other. So if something's being added to my variable, how do we undo addition? We subtract. To undo subtraction, we use addition. We add. To undo multiplication, we divide. To undo division, we multiply. And to undo multiplication by a fraction, like what if our variable is being multiplied by a fraction? What do? Well, we divide, but remember, to divide fractions, we multiply by the reciprocal. And then once again, whatever we do to one side, we have to do to the other. So in example 2, let's solve all of these one-step equations. So in 1, we got y minus 10 equals 20. What is happening? We are trying to solve for y. We are trying to get the y by itself. So what's happening to y? Well, 10 is being taken away from it. How do I undo that subtraction? I need to add. So I'm going to add 10 to both sides. That's going to cancel out the 10 on the left-hand side, leave me just with y. And on the right-hand side, I got 20 plus 10, which is 30. Okay, so y equals 30. And remember, we can always check our work. So if y equals 30, I can plug that back in for y into my original equation, and I want to see, does this actually result in a true statement? So if I plug 30 in for y, then I've got 30 minus 10, which is 20. Does 20 equal 20? Yes, it does. That's how I know I have the right answer. Okay. What about in number 2? 5 plus t equals 14. So I want to get the t alone. What's 5 doing to t? What's being added to t? So to undo that, to move it over to the other side, I have to subtract 5 from both sides. So I get t equals 9. And then I check my work. 5 plus, but instead of t, I plug in 9, and I see, does this make a true statement? 14 equals 14. That is true. Therefore, I know t equals 9 was correct. All right. What about number 3? We got negative 12 equals negative 4 plus x. Well, we could rearrange this to look like that. Okay, negative 12 equals x minus 4. Either way, we have to get rid of this negative 4. We have to move that negative 4 over to the other side. How am I going to do that? I'm going to add 4 to both sides. On the left-hand side, I got negative 12 plus 4, which is going to give me negative 8, equals, and on the right-hand side, I have x. Again, we can double check that. We've got negative 12 equals negative 4 plus negative 8. Negative 4 plus negative 8 is negative 12. So the left-hand side equals the right-hand side. That's how we know we are correct in this answer. All right. What about in number 4? We got 84 equals 4z. What is 4 doing to my z? That's what we're trying to get the z by itself. So what's 4 doing to z? It's multiplying. Remember, if they're right next to each other, we don't see an addition, subtraction, or a division sign. We know that that's multiplication. All right, so I'm going to divide both sides by 4. And I'll get z equals 84 divided by 4. So I can do that off to the side. So z is going to equal 21. Again, always get in the habit of checking your answer. So I'm plugging in 21 in for z. I get 84 equals 84. That's how we know we have the right answer. Check your work. All right. What about in 5? What's happening to b? Well, it's being multiplied by negative 3/4. So how do I undo that multiplying by the fraction? I'm going to multiply by the reciprocal. So I'm going to multiply both sides by negative 4/3. What that's going to do over here, it's going to cancel out that. All right, and leave me just with b. And on the right-hand side, we've got 15. Let me do this in a different color. We've got 15 over 1 times negative 4 over 3. All right, we can cross cancel the 3 and the 15. We can divide a 3 out of each of those. So 3 divided by 3 is 1. 15 divided by 3 is 5. So this is going to be negative 20 over 1, which is just the same thing as negative 20. Okay, so b is equal to negative 20. Again, just to double check our work, we got negative 3/4 times negative 20. Does that equal 15? All right, if I cross cancel, the 4 goes to 1, the negative 20 goes to negative 5. Negative 3 over 1 times negative 5 over 1 is going to be 15. So 15 equals 15. That's how we know we have the right answer. Okay, and for the last one here typed out, we got 0 equals negative 4m. Again, what is happening to the m? It's being multiplied by negative 4. So I'm going to divide both sides by negative 4. And so we got 0 divided by negative 4. Well, 0 divided by anything is just going to give me 0. So m is going to equal 0. Again, double check. Plug in 0 for m. Negative 4 times 0. Well, anything times 0 is going to be 0. So that also works. Okay? The only one not covered here, and I'm going to do this off to the side real quick. Just one last example is like x over 3 equals 2. We didn't do a division problem yet. So what's happening to x? X is being divided by 3. So to undo that division, I'm going to multiply both sides by 3. And that's going to be x equals 2 times 3, which is 6. I can plug that back in to my original problem, and I'll get 2 equals 2. That's how we know we did it right. All right, so these are one-step equations. All we have to do is one step to get our variable by itself. In the next video, we'll up the ante a little bit. We will start doing two-step equations. So how are those going to differ from what we did here? Okay, let me know if you have any questions.